to do the following in this session. First, we're going to go through the report outlines and actually the instructions, and then we're going to go through at least of the two scenarios we have, which has been covered in the week 1 of the visit lecture. And next week, I'm going to finish the other 2. That doesn't mean you have to wait for me. You can start to do your work anytime, and you will get definitely the same results. So first, we're going to start with the project. You will go to the course website on the Canvas, and you will do first 2 things. The first one, I'm going to open the modules in a separate page, and I'm going to go and open the assignment on another tab. So by going down to the, well, actually you cannot see all this stuff, but that's basically what you're going to see. Okay, well, actually same thing. So you will find the mini project should be showed up. Wait a second. Why I can't see the mini project? Can you see the mini project?
On top stuff. Yeah, that's past one. Mini project. This is the third one.
Ah, yeah, it's here. Yeah. Well, things change. Okay. Yeah. So yeah, I'm not going to start anything here. This will be later when you're going to do the submission. We can download the outline for this project, and also we're going to be able to. This should be done here. So first, you have to form the group of maximum 2 students. Remember that in all the cases, if you're going to do it individually or with a partner, you have to finish the 4 tasks. So my advice is join a group. Even if your partner is not going to do his part, you will do two parts. You will be marked fairly because he actually or she didn't do the work. In real scenario, you should have the 4 parts. You should write me something like, well, for me, because I'm going to have a few number of favor for marking. Do I? Yeah, because I gave away most of the marking. But you send me the peer review individually. You don't have to put in your report because you may try to criticize your partner. So you say, he didn't do his part. So you don't have to have a clash with this person by showing him what you wrote about him. That's good, right? You don't have to want. You don't want to have fight, right? Good. Okay. So what we need to do is that each group will need to organize a written project report, and this is no strict limitation for number of pages. You can take as much as you can of the snapshot and put it on your report. There should be a single page at the beginning of the written report to document for each team member contribution for the individual marking. So you say, okay, I did part 1 and part 2. Or I did well, usually it should be task 1 and 1 of the individual labs given to you done by each person. We have 2 individual labs and virtual labs, and we have 2 tasks. Later, well, that's you can read that yourself about the personal reflection, and every team will need to submit a short presentation video, which is less than 3 minutes. In the presentation, you only discuss 1 problem or 1 virtual lab needs to be selected, and I'm going to talk about it briefly about, okay, now that's what's happened. That's how we can explain the phenomena, like how I'm going to explain the phenomena for you right now. And the equation that may be used, you don't have to find any equations. They all going to be available for you. Okay, every team member needs to present in this video, which is true actually. You can make the 2 videos individually and then you can join them. One of the ways to do that, you can make your own PPT file, code on this file with your image on the side as a video. Then the other person do the same thing. Then they join the 2 together and save as a video. Done. When we say 3 minutes or less, for me, once again, don't worry about that. You can go up to 3.5 minutes. You can go up to 5 minutes, and again, to consider any problem with that. The best way to upload this video, put on YouTube. I know that everybody has YouTube channel. Don't argue with that. If you have Gmail, you have YouTube channel by default, and submit the link in the report. You don't have to upload a big file to somewhere and on the Canvas. Nobody actually will bother to download 1 giga file, right? And okay, so once again, the written project report needs to be submitted through the Canvas. The short presentation video may be uploaded to YouTube and the other suitable websites, and the link should be clearly indicated in the written project report and provided in the comments part. So the three scenarios we had, the two scenarios we have at the beginning is about a MATLAB problem on the spool on the track bed. Definitely, you know that we're going to have a part that can, any pass, we're going to put it on the top on moving things. When you get to move it, start to move in the opposite direction. Okay, so I know it's came back, but if I'm going to put so fast, it's going to go to the other side. What's happened is that you remember the diagram we had earlier for the three-body diagram and the kinetic diagram. So the higher the acceleration again to have for your truck is going to cause a force which is equal to the mass multiplied by that acceleration, trying to push the object on the other direction. So what we need to do is we need to use the equations to analyze the forces against the acceleration and find out actually how these things are going to work. Now, one of the things they will say, okay, now how we can apply that in real life? Because I had discussion with one of the lecturers in the university last day, and we were saying, okay, now what is the link between what we're teaching and the real life scenario? If you're going to work in a company that they've been using something like that for years, but they're using the wrong road, but they had luck that nothing happened so far. When you will go there, you will take a look, wait a second, yeah, this was working for a small spool. Don't use a bigger one. If you use a bigger one, you need to have another typing option for that. So by doing some basic calculation, or maybe you're going to use the same code we have here, you'll say, okay, now wait a second, the tying you're using by using just these strips are not good. Use a chain. So this will be your part. Away from that, I will try to give you some information at the beginning before we start with this thing. How to link these things with the real life scenario. For example, if you're going to talk about the topic of the conservative energy, how you can apply that in real life in a future career. Imagine that you are going to work in a company that actually designing or installing the wind turbines. What will be the role of the conservative energy in the wind turbine? How does the wind turbine work?
Spins the turbine.
By the wind. But in addition to that, what do we have? If you actually watch some of the videos for the large size wind turbines, what's happening is that the plate is not going to be stay in the same distance between them. It's not going to be something like, if I'm going to divide 360 by 3, it's not going to be 120. Yeah. So it's not going to be 120 always, but the plates are going to get close to each other for a certain time. Because what's happened is that the plate will be elevated due to two factors, the wind and the inertia. So the plate will go to the top at slower rate. When it's going to reach the top, now we are going to have the force or the velocity to be generated due to the conservative force of the weight. So the weight, when it's going to be at the top, the weight assisted by some of the wind is going to drop the plate at very high speed. And that high speed will cause the energy to be too high due to the huge mass of the plate. And this will keep the continuity of the plates. So I advise you actually to search for some videos for the giant wind turbine. It's actually to be an actual one, not the animation. And you will find this thing. That's one of the stuff. The other thing is about the inertia. If you're going to have a car, or you're going to have a truck, or you're going to have a train, which one is going to have the highest catastrophic level of the impact if the braking system fell? Is it the car, the truck, or the train?
Right.
Train, because it's bigger, though that the velocity is 60 km/h maximum for most of the trains that we have within Sydney, but the brake system doesn't work, probably. Well, that's the word. We are going to have a big, huge mass, and to have the force which will equal to its mass multiplied by acceleration will do a very bad accident. Now, the thing is, that's something that you may not get to learn in the school, but this will be something you will actually get to use in the future to argue that you learned something in the university. So you didn't learn it in university. What's happened if the car brake doesn't work? Not what you are going to do. What's happened if you're driving and your brake system doesn't work? Exactly, the car not going to stop. What's happening if the train brake doesn't work? It's not moving. It's not going to move. Because the brake system we have on the train is working on the opposite way like the one we have in the car. In the car, it's always off. When we want to try to stop it, you press the pedal, you make it on. So it's always disengaged. When you add the force by using the hydraulic and of course some of the power coming from the engine, you will have it engaged, and that will stop it. In the train, they learned the lesson. Till the 60s, the system was, I think that if you can search some of the photos, you will find some photos of the old trolley that you used to have in Sydney. When they reach, for example, the end of the lane, which is going to be somewhere, usually it's going to be and where the ferries are. When the braking system doesn't work, boom, they go to the water. So they learned the lesson later, and they changed the braking system to something we call the clutch brake system, which is something like, if you would like to move, you will apply the power to disengage the brake and engaging the clutch, and then the movement will start. If something happened or you cut off the power, it's going to be done by reverse. So the clutch will be disengaged, but the brake system will be applied. Because not only about disengaging, but also we want to stop the movement. An example for that is the rock crushers in the mining, or the shredders that they have. Have you seen this video when they try to put everything in the shredder that's eating the things? So what would be the worst case scenario for this one if you try to think about the risk assessment? A cat jumped in, you drop your phone and you try to get it back. Okay, or someone under certain influence went inside. Or have you seen the tree shredders? That when they throw the trees, you don't know. Maybe someone crazy and tried to take the cat and throw it inside. So how to stop this machine? You say, okay, I'm going to cut off the power out of it. Yes, that's one of the answers. But the issue will keep the things moving. So I will go with something not going to be printed in your mind and you start to make a bad dream about it. Let's talk about the phone. Oh, wait a second. The phone is the most precious thing for you. Anyway, so the phone is dropped there and you try to stop it at least from being totally crashed so you can take your data out. So most of the machineries, they're going to have something like a paddle. You press it and you make it work. So you press it and operate it. When you remove your feet from this paddle, it will stop immediately. I mean, it's going to not only cutting the power and make it move for a while, but also it's going to be braked. Because we have this system of the brake clutch system. Another example for that is your robotic hand. How many of you saw something like this industrial robotic? So how many of you saw these robotics in real life? You saw it. We used to have 3 of them upstairs. It was the ABB1 250C. So you will ask yourself, okay, now how these machines are stopped moving when you cut the power?
They're very heavy.
They're very heavy actually, but there's a bottom in the system If you saw these machines later, you'll find the control system at the bottom. There's something like blue bottom. If you press it, everything will collapse. Because once again, they're using the same system. They always break. And to make them move, you release the brake at the same time when the motor starts working. So the motor will take the load. When you take your hands off, the motor stops, the brake will be engaged immediately. So it's always engaged. To move it, you are going to have disengaged. Now you learn something in this class. You can go out after 1 hour, tell everybody, not from this subject, because I told them this trick earlier, that you know how this stuff. So you can ask a person upstairs when you see this robotic arm, do you know why this one is standing still? Goes off 1, 2, 3. What else should I tell you about? Well, I actually had more information told yesterday. Anyway, let's go back to the project once again. So that's what we're going to work on again. You have this scenario. We have this rail. It's have a certain mass, certain radius, and certain rates of gyration was going to be bigger as the diameter is going to be bigger, of course. And the truck acceleration range and the coefficient of friction for the static and the kinematic one. We're going to use the MATLAB to do the analysis for certain sets of parameters. So it's not going to be just one set. Try to find 3 sets and make a comparison between the results. So what you need to do with these variable parameters in the table, establish an equation. You don't have to do anything. You will see them there. For determining the parameters below, the normal reaction on the spool angular acceleration, which is the alpha, the acceleration of the spool central points, and the friction force between the spool and the truck bed. Setting the values for the parameters in the table, verify the equation using the MATLAB model, and the analyzing of the effects of the various parameters on the condition of the friction, for example, slipping or no slipping scenarios. Now, the good thing that actually you don't have to do anything. You only have to check one of the results manually by calculation. Just put the parameters you're going to choose in this table and these equations, get the results, run the MATLAB code, get the results, and make a comparison for this instant. The difference is that when you do the calculation, as you remember, we said at this instant. That's mean when the spool is going to be at the initial position. But you cannot do that manually for every different steps of the truck until it's going to be filled. The code will help you to do that. Maybe you can do that in an Excel sheet, put all the equations and do the work. This will be okay. But remember that most of the equations are nonlinear equations. They are going to be differential equation. And this requires a high level of programming like the MATLAB, or even you can do it with the Visual Basic on the Excel sheet. I don't want you to go to this level. Remember that in this project, you're actually only going to be a users, not the programmers. So I assume that you already got the MATLAB on your computer. If not, you can still using the online MATLAB. So the first thing we're going to do is I'm going to teach you how we are going to start with the first scenario. So I'm downloading the file. It's a file. I'm going to go to there. I'm going to right click, and I'm going to extract this file here. Okay, now I'm going to open this file. What we can find readable in this file without even going forward. I know maybe the screen is too small, but you can see here that we have a PPT file. Double click on this one, and you will find some information about the free body diagram and the scenario you are going to have in this example. So that will be my initial state. My truck doesn't move. Okay, so I got this file. If I would like to take this one to the Word document, what you are going to do? What are your options? What's your option to take this one to Word document? You can take a snapshot, right? Wait a second. I will show you something that you can use not now only, but this will be go with you through all your rest of the degree when you are going to make a report or publication or assignment. So I'm going to open the Word document here, and we will see what are the different ways to put an images on a Word document. So the first option we can do is choose the option of the print screen. Okay, I printed this screen, and I'm going to go to here and paste. And then I can trim this image, right? This will be the option number 1. And actually, there's some of the free softwares, like the screen recorder, is going to have also a snapshot, which is going to give you better quality than the print screen option. That's option number 1. The size of the image is going to be quite large usually, and it's going to have some blur. The other option is I will go to the PPT file, and I'm going to select that. Right-click, Control C, and then I'm going to go to here, paste as an image. Now it's going to be an image, very light, very clear. Copy that and put it on the Word document. Now, obviously, you can see that the later is more clear than the one we had earlier, and also is lighter in weight. So your size of the file not going to be end up as 100 gigs because, no, actually 100 megas because you add too many images. And the third way to be done is, well, that's something you don't know actually how to be done. I can sketch a 3-by diagram myself using the Excel. I always use the Excel when in the shape that you can see in my PowerPoints. Like I can make a circle, I can give it a different color, you can fill the shape with a different color, and then you can choose the center points again to be another circle that will be sitting in the middle. So this will be the point G. Okay, doesn't have to be to scale. And then I can add the forces by adding the arrows. So I'm going to have horizontal arrow. Maybe this is too thin, so I can change the outline, increase the weight, and bring it to here. And you can, of course, copy and paste this one if you don't want to bring another arrow. Okay, and this can be something like the friction force here, and we can have the normal force and the weight the same way. Okay, so that's an example. Now we want to put some of the words or writing. Oh, by the way, even you can put something like insert an arc if you would like to put the omega. Okay, so for this arc, you can add the arrows, outlines, and you can put the arrow at one end. Okay, and you can bring this one to here, and this will represent the omega. Okay, now we don't have any writing here. We don't have any wordings. So what you can do is insert, and you can insert an equation. This can be one example. So now you can type the equation here. I will put that this one to be the omega 1. So I will put omega underscore 1 space. And now I have the word omega 1. I can enlarge the font here. Okay, and the same equation you can copy and paste it here, and this will be something like the mass m dot ga underscore x. Okay, so this will be the mass multiplied by the acceleration x. And after you finish with all this drawing, you can make that as an image by going to the home and find and select an objects, select those, Control C, and paste as an image. Now we have it as an image. We can take it to the Word document. Well, because you already have been given all the, by the way, it can go to a PowerPoint as well. It doesn't have to go to the Word only. Because we're going to bring all the stuff to here, I will give you another hint. Usually you're going to have problem with the moving images on your Word document. Had you had this problem before? When the text is going to go around the image. So what you can do is you can simply insert, sorry. Okay, you can simply insert a table, and this is very highly recommended. That's what I'm doing actually in most of my work. Paste the image here. You can control its size. Make it somewhere at the middle. And you can use this one to write down the caption of the image. Figure 1. And write down what this figure is. Of course, you don't want to have these outlines in your report, so simply choose no borders. Now, it's much better. Now the text is impossible to interference with the image. The image not just keep moving. You can fix it here. You can pass the text to go to above and below according to your work. Okay, so now I'm not going to save this one now. I don't need it. And I don't get to use this one anymore. So that's the way. Will be the case number 2. When we add the velocity, that's position 1, that's position 2. That's the free body diagram, and this is the kinetic diagram. The x dot dot is actually going to be the acceleration, the horizontal acceleration, which is a linear, and the theta dot dot is going to be the alpha, which is the angular acceleration. Okay, again, let's continue with the work. As you can see here, that's the case of no slipping, and this will be, oh, sorry, no slipping, yep, and that's the case of the slipping. Okay, and this is further information about the work. We're going to check that using the MATLAB and the Simulink and see how it's going to work. So now, once again, I don't need the week 9 tutorial or week 8 tutorial. Okay, again, we downloaded this file. I will go to the unzipped file here. For you, if you're working on computer, I mean PC, you can make a folder on the C drive. I mean, open the C drive and anywhere, make a folder called the BH folder. And then you can save all these files there and link the directory of the MATLAB to this folder. This will be the easiest than put it in your document because you will shorten the directory and this will make it much easier for you to find it. If you do that on the Mac, well, find your way, help yourself. I'm not an expert with the Mac. I don't know even how to do the right click or the left click on the Mac. Sorry for that. Okay, but anyway, you will find a way. Now, the other way to do the work is just do the work using the MATLAB online. So when you download the MATLAB, you are going to have an account on the MATLAB or the MathWork. I'm going to go to my account. I click here. Actually, I've been waiting for a while, so this will cause a problem. You will find in my account, we have something called the MATLAB drive. Click on the MATLAB drive. It's going to give me an error usually. Yeah, no, okay, now that's the MATLAB drive. So you can see it's something like the one drive. So the only thing you can do is just go to here and drag and drop this file to here. I already did, so I'm not going to do it. Then you will find this file available for you. So you can see that this is the MATLAB example we have. If you do that, for example, you are a Mac user, I advise you, most of your laptop are quite small. In all the cases, if you're going to use the online one or you're going to have the normal one, try to connect that to external screen. This will give you more option to see the things more clearly. Anyways, if you don't want to do that, it's not going to be an issue. So now we are here, and this point, we don't have any differences between the Mac user or the PC users. Now here, in the what we call the browser version, everybody is going to be equal. Now I'm going to go to the MATLAB online. And usually this version going to give you the one that you downloaded already, which is for me, I downloaded 2024B. This is the recommended version because the 2024A is the older version. It's not going to open the files probably.
So,
Yes.
do you have to re-download MATLABs every like 6 months to have the rest, or can you just
No,
update
you
it?
can upgrade it.
Oh, okay.
There's an option somewhere. I don't remember. I hadn't done it for a while,
Okay.
but there's an option for
I
that.
just wanted to make sure.
If you have an old copy, if you, and you don't not sure about that, just remove it and
No, I got 20. I got 20.
okay. Now here we are. I just closed some of the windows that were open from yesterday, and the first step we are going to do, we need to clear both the workspace and the command windows. To do that, I'm going to write down clear, and this will clear the workspace, and I'm going to write down CLC to clear the command window. Now everything is clean. I'm going to start to do the work. I will look for the scenario that we are talking about, which is the spool on the trackpad. I'm going to double click on that, and this will open the folder that we have. Actually, if you're going to put the zip file there, there is something here which called the unzip order. So you write down unzip, you write down the file name, and it's going to unzip it for you. Then you're going to open these things. But don't go through this step. Just unzip it earlier and upload it as unzip file. Now we can see here we have the multiple files. The main important one for us is going to be the first one. The demo start here, please. Don't double click on this one. Right click and open, or just select it and open from here. Anyway, right click and open will be the best option. Now you'll ask me why I'm doing that, why I'm not double click on that, because I tried that earlier and it gave me an error. I mean, well, that didn't run. It didn't run unless I do the right click and open. And you'll see the same thing. Maybe it's explained by the visitor lecturer. Anyway, you have to watch the video. So that will be the scenario we're going to simulate. But before that, what we're going to do in the first task is we're going to apply the Newton's second law and drive the mechanical equation of the motion, or what we call the EOM, for the spools. We're going to apply the EOM for the case of the study where we are going to assume that the spool does not slip. And later is going to be when the slip is going to be occur. We will open the run simulation of our system and compare the simulation results against the drive results. So that's number one, is that we need to change the parameters for our work. But before that, you can see if I'm going to click on this file, it's going to give me the MATLAB calculations. This will be a new folder. And the good thing that you will find that the free body diagrams that we had in the PowerPoint are here. And also is going to tell you what is the annotation of each one of the letters we have here. The free body diagram, applying the second Newton law, and you will find these are the equations we are using. Sigma of the forces to the x-axis are equal to the mass multiplied by the acceleration. That's what we have on the free body diagram, and that's what we have in the kinetic diagram. Well, actually, I hadn't tried that, but let's see how we can take these equations to your report. Do we have copy? We don't have copy. Let's see if I'm going to do the Control C, and let's go to the Word document and see what will happen. Paste. Oh yeah, well we had it as an image. That's fair enough. It's quite blur. Okay, so if you would like to type it, this will be okay. And there's another chance to do that, which is, as I told you, I'll just remind me, please, tonight, I will send you what is the app I'm using for recording my screen and take a snapshot for it at very high quality. Then you can use it by simply click on the icon of the camera. Then you come to here, open the thing, and you'll take the snapshot and bring it to your document, which is going to be very clear. So that's the general situation. That's the case if you have no slip, but the acceleration B is going to be constant. And the second, these are the equation. You can put the parameters in, by the way, and get the result manually. If you would like to type it, this will be okay. If you would like to write it and take a snapshot and put it on the report, this will be okay. Yes.
Question. When we're writing, obviously, like we do it and then we verify with MATLAB, in the report, I assume you want to see our handwritten calculations as well.
It should be neat.
Yeah, yeah.
So something I can read.
Yeah, of course. When we do our handwritten and then we verify with MATLAB, whether we're right or wrong, should we put those calculations in so we can talk about where
Exactly.
we went wrong?
That should be in
So
the
don't just do it over and over again until you get it right.
No,
Just
no, no, no.
whichever
no.
the first part that you do,
Exactly.
put it in and go, oh, I was wrong. Here's why using verify with
Exactly.
MATLAB. Okay.
Okay. And just remember something that
If you get it wrong.
wait a
You
second.
talk so about getting it wrong.
That's something we also talked about last day with Brown. It's about, okay, now many of the subjects in the universities nowadays, not just us, they're ignoring this part. Okay, now everybody accept that the code you have is going to be correct and you will keep using it to get results. Now the question is, if I get to make a model for a heat exchanger in the MATLAB, what will be the way that I should know that the calculations are correct? I should have an experimental work with the same conditions and verify the result against each other. Then I will say, okay, now my model is compatible with the actual one with a percent of plus minus 5%, which usually again to be acceptable. This range, just imagine the 10% range is acceptable, but the best range is going to be something like a plus minus 3 sigma. Sigma is the standard deviation. Now, why I mentioned that, because one of the students yesterday, he told me why they have to teach us statistics in the engineering, because we have something very important, more important than making something. I mean, design something and manufacture it, is the quality assurance of it. And the quality assurance always going to be done by a process called the SPC, which is the statistical process control. I will give you a hint about that, but I mentioned the 6 sigma as an example, which is going to be something like you calculate the sigma, which is the standard deviation, and your acceptable range should be between the minus 3 sigma and the positive 3 sigma, which is going to be in total 6 sigma. You heard the term 6 sigma before? You haven't. Okay, we're going to talk about this one later. It's not a part of your syllabus anymore, but it was before. Okay, now the case of the spool slipping, and in that case that the acceleration is not going to be the same later at the point B. And once again, we have the equation. Now implement the calculation in the MATLAB. So you can see that this is a code for the MATLAB, and I would like to check if this code results. What we need to do is, let's check where are the parameters here. It's not here. Okay, so let me check here. The values for these functions, spool truck calculations to be added. So it's going to be done somewhere else. But anyway, if I go to click here, I can see that nothing has been highlighted. Nothing has been highlighted. So definitely this will come from another function. So let's go back to here once again. These were the equations, and we're going to go for the case study number 2. The case of the slip need to be determined, and this will be another code. We're going to click on this one. It's going to give me all the equations in details. Okay, and these are the equations for non-slipping. Okay, it's already been given to you. If the slipping is going to give you a false, that means that the spool is not slipping. This will depend on the acceleration and the mass, of course. And the case is going to give you a true, that means the spool is slipping. So let's start with the parameter changing. The first thing we're doing is type clear here. Second step, change the parameters. So you can see that we have a range between 50 to 500 for the mass. I will choose 250. It's hard to be done with the slider, so just go to here. Write it down as 250. Now you can see that something has been generated in the workspace. For the K, I'm going to choose 2.5. And for the acceleration, I will choose 10. Okay, and other things like the I is going to be calculated, which is the mass multiplied by the K squared. The radius can be changed, of course, but I'm going to leave it as it is. The G will be the same. Now, the coefficient of friction, I will leave it as it is now. And now we are going to see how if we're going to just run it, it's not going to work. So now these are the parameters that has been calculated for us. If I would like to get the this file working, click on that and tick it once again. So you can see that the parameters has been updated here. All the parameters has been updated. Still, we didn't have any calculation yet. Let me try to run this section. Okay, yep, by now this parameters has been calculated. Nothing happened in the first state, and that's what will be happening on the second state. Now we are going to compare these results. Actually, more details you can find it in the video done by the visual lecture. Now we're going to run the Simulink code. So we need to open the file, which is the BH model or the baked hot model for the spool and the track SLX. So if you get to search here, you will find this one to be here. Right-click again and open it. So this will pop up a new window because now we are moving from the MATLAB, which is this one, the MLX, to the Simulink, which is the SLX. So the MLX is the MATLAB, the SLX is going to be the Simulink. Now it's coming, still uploading. You can see it's reading the data from the workspace, and it's going to show up as a new window. You can actually read the details here. You open this one, you're going to run it, and you're going to get the results from the purple boxes. Okay, now this is the MATLAB code. I'm going to click on this one to run it. I don't have to run sections or run it all. And it will give me some of the results as well at the same time. So you can get all the results from this point. Okay, these are the value for my calculations. Now we are going to go back once again to the file that opened for the Simulink. Okay, we change the parameters. The model that done by the MATLAB has actually built in here as a Simulink. Also, the measurements are going to be the following. First, we have the x1, we have the x velocity 1, and we have the acceleration 1. The second state, we're going to have the velocity 2, we're going to have the acceleration 2, and sorry, the displacement 2, the velocity 2, and the linear acceleration 2, and the angular acceleration. And here we have the calculation for the force, for the friction force, and what will be the case of the slipping or not slipping. You can read is slipping, then the value is going to be equal to 1 and 0 in case of not. Now, how we can use these files, if you're going to go to this one and double click on it. The problem with the web version is that sometimes the left click is going to be a right click. I don't know why. Double click on this one. Now it's worked. And you can see that we have a graph, but no information are in it. This one is going to be for the displacement 1, velocity 1, and the acceleration 1. Now, how to fill this one? I get to run the file. So it's doing some calculation, and also is going to show us the track. Now you say, okay, where's the track? They found that this is track from the bottom. So I can move this one by press the roller of the mouse and drag it down. So the simulation is finished. Let's go back from the beginning. So that's actually what's happening. When you move, this will go outside the track. So we need to do the calculations for this one. Actually, it's been generated, and you will see that on the graph we had. Click on here. This is scope 1. You'll say, okay, now where are my readings? I cannot see any, just something here. How to make this one to sit in the space of the graph? Take that. Okay, now these are your graphs. So this is the acceleration that we fix it to be 10. The displacement is increasing with the time, and the velocity is also increasing with the time. So you can see that the velocity will start from 0 to reach the maximum at the end, when displacement is going to be about 14 meters, where the velocity is going to be about 17.5 meters per second. The acceleration will remain the same. Now that was the first thing we have. I think that you can print that file, print to a figure, but the best option for you is just take a snapshot of this one and put it on your document. Now let's check about the other results we have here, about the state number 2. So again, to click on this one. Okay, now once again, these are the graphs, including the theta. Click on this one, and this will be the results we're going to have. So that the change of the velocity within the time, displacement within the time, and the acceleration within the time, and the angular acceleration within the time. Finally is the graph for the forces. Okay, so once again, this will be the measurement for the slipping or non-slipping. That's if it's slipping, you're going to have 1. In case of non-slipping, we're going to have slipping, of course. You can see that this is a blue thing. Okay, so once again, for further details about what we're doing, just remember that here I'm not do the solution for you. I just break the ice, so you're not going to be scared about using these things. Now, how many of you already know how to control this stuff? Anyone still have a problem? All good? Okay, so later what you need to do is just change your parameter, have something like 2 or 3 sets, do the calculation for one of them, take the results from here, compare it with your hand calculation. They say, okay, now the code is verified, then you start to run the other codes and make a conversion between different stages. Like, for example, the bigger the mass is, the bigger the acceleration, the angular acceleration is. The bigger the mass is, the less friction force, the less slipping possible they're going to be, and so on. Okay, so that will be your first part. Now, I prefer that I stop the recording now. I'm going to make the recording for the other part, and we are going to have 2 separate videos. It's much easier than have a continuous one. You don't have to go forward and backward every time you want to find something. So here we go, and stop the recording, and